Okay, here's a question which is helpfully flagged up as being an exact Poisson test, but how would I know that? Well, there's a claim. There's a claim that there are at most 10 floors in a 100-meter roll of cloth. So we've got a space of 100 meters of cloth, and we're counting events occurring in that. So I'm counting events occurring in a fixed space. So this looks like Poisson. I have to assume that the constant average rate, and I have to assume that they're independent. Oh, I've just done the last part. So those things, assumptions that we need it to be Poisson, or what are we going to say at the end? Okay, but this is a Poisson distribution. So before we even write down our hypotheses, X has a Poisson distribution, we think. What's in dispute is what the parameter of that Poisson should be. So, because I've set that up, when I come to the first step of my hypothesis test, is my hypotheses. So I need an H0 and an H1, and they're going to be about lambda. I've defined my distribution, so lambda makes sense. So, what's claimed? Well, we've got this figure of 10. That's the sort of claimed number of floors. So there's a claim that lambda is 10, except they're actually claiming that it's at most 10. Okay, so if lambda is 10, then the claim seems to be okay. What would disprove the claim? Well, our lambda being less than 10 is actually, they're saying it's at most 10. So lambda being less than 10 would be fine. It's only lambda being bigger than 10, all right, that would tend to disprove the claim. So now we have a one-tailed test, not a two-tailed one. So that's actually going to mean the critical value is slightly nicer, but we're not there yet. This is my hypothesis, so that's my first step. Okay, the next thing we calculate is our test statistic. Okay, so my test statistic is, well, for these exact tests, it's just a probability. I've got to work out the correct probability from the observation 14. Now, which probability I calculate depends on whether this observed figure is greater than the claim would lead you to believe, or null hypothesis would lead you to believe, or less. And for a Poisson one, this is just incredibly easy. If I think the mean's 10, but I've actually got 14, if anything, this 14 is big. So it's going to be the tail I need to look at. The probability I need to look at is, here's my diagram of outcomes, 14, 15, 13. Okay, what's going to be the small probability, less than a half? Well, it's going to be the probability being 14 or more. 14 is a bigger than expected figure. So is it so big we've got some evidence of something? So I need to work out the probability being 14, 15 above, but not these. Okay, so the probability I need, the boxes are big box minus little box. Okay, it's an exact test. Okay, it's got to tell me it's exact test. Where did it do that? Use an exact test. Okay, sometimes we can look at where you have to use an approximation. But it's an exact test, so we do the normal Poisson probability method. So it's two probabilities taken away. It's the probability of everything. Actually, that's 1, isn't it? So it's 1 minus the probability of the little box is x being less than or equal to 13. So I go into my Poisson mode on my trusty calculator. So Poisson CD, that's 3. And I need to set this up with an x is 13 for this one. Lambda is, what have I got for my lambda? I use the lambda according to the null hypothesis, so I'm using a lambda of 10. I don't know if you can read that. And I get an answer of 0.864, which I need to take away from 1. So it's 1 minus 0.86446, which is 0.135554. Okay, so that's my probability, so that's my test statistic. So now I need a critical value. So my critical value is, well, the decision we have to make is, do we just work with the significance level? Okay, use an exact test. It doesn't say a significance level. Okay, well, the traditional one is at the 5% level. So let's assume the question says at the 5% level. So do I need to halve it or not? Well, I've got a one-tailed alternate hypothesis. So in my diagram, okay, always draw the diagram, okay. If I get exactly 10, then of course I'm going to accept the claim. I'm only going to reject the claim for very large values of lambda. Now I have got a larger than expected lambda, but I need to be sufficiently large that I'm in this critical region, which is of size 0.05. So my critical value is 0.05. So my comparison, so when I do my comparison, I compare the test statistic probability, okay, which was this 0.13554, and I compare that with the 0.05, and it's greater than. So am I in the significant bit there, or am I in the not significant bit here? Well, this tail is really quite small, 0.95. The probability I've got doesn't fit into that tail. It's a bigger probability. So when the probability you get is bigger than the probability you've got for your critical value, then that's when we say it's not significant. So this is not significant, so therefore, in terms of my hypotheses, I'm going to be accepting H0. But of course the true interpretation is when we say that in context. So we're accepting H0, so when we accept H0, okay, and it's not significant, we always, for our conclusion, start by saying that there is no evidence at the 5% level that what? Well, we've got to reach a conclusion about the claim. The claim was that there are 10 flaws, or maybe less, okay? I have not got evidence for that claim or against that claim. Well, the claim was the null hypothesis. If I believe that lambda is 10, I'm believing the claim. I'm accepting that, so I'm accepting the claim, so there's no evidence that the claim is false. And that will do. I can say the manufacturer's claim. Okay, always try and put it in context. This is a claim made by a manufacturer. Okay, you don't need to restate the claim. So I've got my conclusion step, I've got my hypothesis test statistic, my comparison step was here. It's nice to flag up those 5 stages just to make sure you've done all the things you needed to. Lovely, that one's done. Oh no, it isn't, because I had to state the assumption required for your test to be valid. Okay, can't fit it in here, but for the last part of the question, we need to assume that the conditions for a Poisson. So we are counting the number of flaws in a fixed space, but they need to be flaws need to be 2 things. They need to be independent, because they need to be independent events occurring at a constant average rate, yes, and at a constant average rate. So actually, it should really say, it says state an assumption. So if the wording was like that, you might get away with just one of these. But it's far more likely, if there are 2 assumptions, that it wants both, and there'd be 2 marks. So watch out for the number of marks being awarded. Okay, we have done with this question there.